And that is biconditionals and definitions. Okay, biconditionals and definitions. iPad's away, unless you are taking notes on them. Sam, what are you doing on your iPad back there? Yeah? Okay. We good?
Yeah. I type like this. So it seems
I know, you look like you're playing games when you...
I have split screen on here, so
Okay.
I'm not.
Okay. Thank you. Thanks for verifying. Okay, here it is. A biconditional. So we talked about a conditional, right? What is a conditional? It is an if-then statement. So we had conditional, converse, inverse, contrapositive, all of those if-then statements, okay? A biconditional is no longer an if-then statement. What happens is it's a single statement that takes out the if and then, and it puts in if and only if, okay? And I'm going to help you out here with your biconditional. Rather than have to write if and only if, rather than have to write if and only if every time, you can write IFF, and that is if and only if, okay? See? Beautiful. So biconditional is going to use if and only if. Okay? That's the monkey way. You're going to write it as IFF. So if you want to write all this, you're welcome to. But if you would like to write less, IFF. Okay? All right, so here's the deal. You may only use a biconditional if the conditional and its converse are both true. So rather than have to write conditional and converse every time, you can check, is this one true? Is this one true? If they are both true, you can just turn it into one biconditional statement, okay? So here's an example for you. If I said, if the sum of the measures of two angles is 180, not in, is. If the sum of the measure of two angles is 180, then the two angles are supplementary. Okay? Is that a true conditional? Yes, this one is true. Okay, so if that's true, then what you're going to do is you're going to check the converse as well. So what would the converse of this be? Right, if the two angles are supplementary, then the sum of their measures is 180. Is that true? Yes, that's true as well. So if the conditional is true and the converse is true, then instead of writing the conditional and the converse, you write the biconditional. So the biconditional then takes your original conditional, so it's going to take this conditional statement, okay? It's going to take out the if, it's going to take out the then, and in place of the then, it's going to put if and only if. So it would say, for your biconditional, it's going to say the sum of the measures of two angles is 180 if and only if, so IFF, the two angles are supplementary. Notice I use a lot of shorthand. I'm fine with you using shorthand on these, okay? I know it's not English class. You may use shorthand. The two angles are supplementary. Okay, so that is your biconditional. As long as the conditional is true and its converse is true, then the biconditional is the only statement you really have to make, if and only if. Questions on that? Okay, so if I said, if two angles have equal measures, then they are congruent. Is that true? If two angles have equal measures, then they are congruent. Yes, okay. If I flip that, the converse, and I say, if two angles are congruent, then they have equal measures. Is that true?
What?
If two angles are congruent, then they have equal measures. Did I say that wrong?
Yes.
No.
Yes. Also true. So both are true. So you could say two angles have equal measure if and only if they are congruent. Okay? Both are true. You can write the biconditional. The way we show that in terms of our P and Q, remember we did if P then Q, if Q then P, if not P then not Q, if not Q then not P. The way we show it in terms of that is for a biconditional, you say P, and then your arrows go both ways to show that you can do it either way. So for this, you would say P if and only if Q. Okay, that's how you would say that. Okay, so the reverse is also true. If I give you a biconditional, you should be able to write the conditional and the converse for me. So let's say I give you a biconditional. And my biconditional says array is an angle bisector if and only if it divides the angle into two congruent angles. Okay, so now I'm giving you the biconditional, and you should be able to tell me the conditional. And its converse, okay? So now you're gonna take out the if and only if, and you're gonna put in the if and the then, okay? So what would my if then statement, what would my conditional from this be?
If
Mm-hmm.
array divides the angle into two congruent.
Okay, that would be the converse, right?
Oh.
You wanna start at the beginning. So if array is an angle bisector, that's where your then comes in. Then it divides the angle into two congruent angles. Okay, so that would be your conditional. What's your converse for that conditional? If what? And here's where you have to be a little bit careful because you still need a subject, and it is not a good subject for this one. So if array is an angle bisector, then it divides the angle into two congruent angles. We want to say if what? What's it that we're talking about? This it here? We don't want to say if it divides the angle. We want to say if the ray, right? We're talking about the ray. So if array divides the angle into two congruent angles, then it's an angle bisector. So just make sure you're being clear with what you're talking about. Don't call something it at the beginning of a sentence when we haven't established what it is, right? Call it the ray, or call it whatever it is that we're talking about. Questions on that? Okay, we're going to talk a little bit about what makes something a good definition in terms of the math that we're going to be doing. Am I okay going to right there right now? Okay. So, good definitions. They're going to have three different qualifiers for them. The first one is you have to use clearly understood terms. So if you've ever watched The Little Mermaid, they have on there a snorfplat. Do you know what a snorfplat is?
No. Never seen
I'm sure
it.
someone in here does. Anyone remember? Or a dinglehopper?
I know what that is.
Do you remember?
It was the fork.
That was the fork, right? But a dinglehopper, nobody knows what a dinglehopper is. We know what a fork is, okay? The snorfplat was what? The pipe, right? And we know what a pipe is. We don't know what a snorfplat is. So use words that people know, not words that some bird made up for those things. Clearly understood terms, okay? Second thing you need to make sure of is that it's precise. So you don't want to say things like large, because what is large to an ant is not large to you, right? You're large to an ant, and you're probably not large to you. Or you don't want to do sort of, okay? These are the bad ones. You don't want to say almost or kind of, okay? So none of these guys. No large, no sort of, no almost. We don't want those. Not maybe. We want like exactly. Exactly is a great word for a definition. And then the third thing is it needs to be reversible. So if you can write a biconditional, it's a good definition. Okay, if you can't write a biconditional with it, it's not a good definition. So we're going to talk about a couple definitions and determine, is it reversible? And if so, we're going to write a biconditional, because a biconditional is a good definition, really. So this is example 3. If I said a quadrilateral is a polygon with 4 sides. Do you know what a polygon is?
Yeah.
What's a polygon?
Oh, sorry.
Any shape that has straight lines, no open edges, no like openings anywhere, right? It's a closed figure with straight lines to it. A circle is not a polygon, right? Okay, so if I give you this, a quadrilateral is a polygon with 4 sides. If I can write the conditional and converse and they're both true, that's a good definition. That means I could write a biconditional, and a biconditional is a good definition. So if I were to put this as the conditional, if a figure is a quadrilateral, then it is a polygon with 4 sides, or if a polygon is a quadrilateral, then it's a figure with 4 sides. You could do it either one of those ways. The converse, well, first of all, is that true?
Yeah.
That's true. If it's a quadrilateral, it's a polygon with 4 sides, okay? Reverse it. If a polygon has 4 sides, then it is a quadrilateral. Is that true?
Yes.
Yeah, both of those are true. So if you can reverse it like that, that means this is great. We like it. It's a good definition. So your biconditional, what you would write from that would be something along these lines. A figure is a quadrilateral. And then what comes next in a biconditional? If and only if. IFF. If and only if it's a polygon with 4 sides. Okay, so writing a biconditional from the statement they give you to determine is that a good definition or not. So this would be a good definition. Okay. All right, tell me if these are good definitions. Example 4, last one. Is it a good definition? A fish is an animal that swims. Is that a good definition? Based on the constraints we put on a good definition. Why not?
Because if you like you get the conditional and like the converse is like it doesn't make sense.
Okay, so if an animal is a fish, then it swims. if an animal swims than it is a fish. Converse is not true. Give me a counterexample.
I don't know.
Polar bear.
A duck.
A polar bear, a duck. So if you can find a counterexample, not a good definition. Okay, so we would say no, this is not a good definition because a duck swims. Yes.
So, and also it's not precise, right? Precise.
It doesn't give any like sort of, kind of, any of that. So
Okay.
I wouldn't necessarily say it's because it's bad because it's not precise. I'd say it's not a good definition because it's not reversible. No, fish can swim, but ducks swim also. So it's a bad definition to say a fish is an animal that swims because there's other animals that swim. You want to be more, well, you do want to be more precise than that. You want to be more specific, right? Be specific. How about this? Rectangles have 4 corners. Okay, I'm not asking if it's true. I'm asking, is it a good definition for a rectangle? Why? Because, well, but a square is a rectangle, right? Is there another counterexample you could give me? A trapezoid has 4 corners, but is not a rectangle, right? So this is not a good definition. And you could do, depending on what the quadrilateral looked like, yeah, like you could do something like this, right? But 4 corners, but not a rectangle, right? So that would be a good counterexample. How about giraffes? Are animals, yeah, with very long necks.
That's not a good definition.
Why?
Because not.
Because people could have a long neck and you are not a giraffe. Or an ostrich. People would say an ostrich might. So this very long, right, that's relative. What is long to one person is not necessarily long to another. So you can't use words like that to give the definition. We could say an ostrich would be a good counterexample. So not a good definition. They do. It's true. It's just not a good definition for that animal. Right? Justin, I'm going to take you outside after this, and we're going to duke it out. You guys totally put your money on me on that, right?
Yeah.
Yeah.
He's not like a football player.
All right. A penny is a coin.
Are you recording?
It's not true.
Sure am.
I'm gonna go back and watch this just so see if
A penny is a coin worth 1 cent. Is that a good definition?
Yes. No.
Yeah.
Yes. 1 yen.
No.
If a coin is a penny, then it is worth 1 cent. Is that true?
Yeah.
If
It's worth 1
If a
cent.
coin is worth 1 cent, then it is a penny. Other countries don't use cents, though.
Yeah, that's right.
They use. No, they don't.
No, but it can be worth 1 cent. Like 1 yen is worth 1 cent.
Yeah, like 1 peso is worth 1 cent.
No.
I don't think there's any, because money changes, right? Inflation rates and whatnot. No, there's nothing that's always going to equal exactly. Like the US dollar versus Canadian money, they're never the same. So anyway, this would be yes. Good definition. It's precise. It's to the point. It follows our rules. It's reversible. So that would be a good definition. Okay. Questions on that?
So